the video for geometry for assignment 12, solving triangles, which we covered a little bit last time, and word problems, solving word problems using the trigonometry stuff. When it says solve a triangle, that means you're finding all the missing parts of a triangle. A triangle's got 3 sides, it's got 3 angles. They got to tell you 3 of those parts, and you're going to find the other 3. We're going to do some examples with that. Remember the angle of elevation, angle of depression. Angle of elevation is always going up. So it's got your straight horizontal line there, and then it's an angle going upwards. That's angle of elevation. Angle of depression is going down. So some of these word problems will use those, and you'll have to draw a picture and know where that angle of elevation or angle of depression is located at. For angle of depression, you got your line going across, and then it'd be like you were looking down. So that angle would be an angle of depression, and if we finished it out, you'd have a right triangle there. So angle of elevation, angle of depression. If we're looking at this, just notice here that I got 4 angles here. Just to explain a little more about angle of elevation, angle of depression, if you're in the airplane, so if you're up here in the airplane, and you're looking down at the person standing there on that, looks like a cliff, then this angle, ignore that, would be an angle of depression. So that's the angle of depression. Pen's messing up pretty good. If you're the person and you're standing here on this cliff and you're looking up at the airplane, then this would be an angle of elevation. Notice that those 2 angles, as long as the ground and the airplane here, the way it's flying, is parallel to each other, those 2 angles are alternate interior angles, so they're actually going to be the same. So if again, if you're in the airplane and you're looking down at this person on the ground, angle of depression. If you're the person on the ground and you're looking up, angle of elevation. And these are congruent to each other, because if these 2 are parallel, ignore all that. If those 2 are parallel, then they're alternate interior angles, and they have to be congruent. Now, if you're, no laughing at my drawing here, if you're the person and you're looking down at this dog down here, angle of depression, ignore all that. If you're the dog and you're looking up at the person, angle of elevation. Not sure why my pen's messing up so bad. All right, we're going to solve a few of these. And this is what the worksheet's going to look like. It'll be some of these problems solving triangles, and then it will be problems, word problems. All right, solving these, I got rid of one of them. Solving these, remember to use SOHCAHTOA. Sine, cosine, tangent, each part tells what they are, so remember that. And then to set up each equation, trig name, the angle, equals, and then the fraction. So on this, several different ways you could do this, and you can also use Pythagorean's theorem. Don't forget it, a squared plus b squared equals c squared. If you wanted to do that, you could use Pythagorean's theorem. In this one, we could use Pythagorean's theorem to find x down here. Since we've been dealing with the trig stuff, I'm going to use the trig stuff most of the time, except to find one of the angles where I know that the 3 angles of a triangle add up to 180. So first thing, we're going to find alpha first. That's this angle right here. So we're going to find that angle. We label the triangle. That's the opposite. That's the hypotenuse. This is the adjacent. The ones we care about this time, since we're finding an angle, are the opposite and adjacent. We look up here at the SOHCAHTOA. Opposite and adjacent tells us that we're using the tangent. So the first equation I'm going to set up is tangent of our angle, which we don't know, which is our alpha, equals, and then we want opposite over adjacent. So 15 over 22. We're finding an angle, so remember on your calculators, when you're finding an angle, you got to use that second button, and the calculator is going to do all the work for you after you set up this equation. So I just grab my calculator and I hit second tangent, 15 divided by 22, hit equals, and it tells me 34.2868, so on, so on, so on. I said round all the angles off to the nearest degree, so we're going to round this off to 34 degrees. So we now know that this angle is 34 degrees. Then the next thing I'm going to do is I'm going to find x. And since you know the opposite and the adjacent, you could use just about any of the, or you could use 2 of the 3 trig ratios to be able to find x here. It doesn't matter. So I'm going to stick with this angle, the 34 degree angle that we just found. And I'm going to say, since we already got the triangle labeled opposite and adjacent and hypotenuse according to that, I'm going to deal with the opposite, and this time I'm trying to find x, so I'm going to deal with the hypotenuse. So opposite and hypotenuse tells me I'm using the sine. So I set up my equation, sine of our angle, which is 34 degrees, equals the opposite, which is 15, over the hypotenuse, which is x. A little more work to do on this one because the calculator's not going to do all the work for you. First thing though, you got to get rid of this word right here. So we take our calculator and we hit sine 34, hit equals, and it tells me 0.5592 equals 15 over x. Remember, you put a 1 underneath this. Now we got to solve that. We cross multiply, we get 0.5592 times x equals, cross multiply this way, 1 times 15 is 15, and then the next step, you divide both sides by 0.5592. These cancel out, and we're left with x equals whatever this tells us on the calculator. So I take 15 divided by 0.5592. Remember, your numbers should get bigger. And I come up with 26.824. And on segments, we want to round it off to nearest tenth. So we're going to say 26.8. 26.8. So we now know x equals this. We know that alpha was 34 degrees, and the last thing we got to find is our theta. Well, to find theta, the easiest way, we know that this angle's 90, that angle's 34, so we just add those two. That's 124, and then we subtract that from 180. Have to borrow there, 56 degrees, so theta is 56 degrees, that angle is 56 degrees. So now we've solved the triangle, we've got all 3 parts, and that's what the answers you would write in the blanks or on the homework. Again, different ways to do it. If you wanted to start off and find an x first, you could have done 15 squared plus 22 squared equals c squared. Because x is the hypotenuse, using Pythagorean's theorem, you could have solved it that way. Then went back and found the angles. Next one, On this one, I'm going to start off finding the easiest thing first, and the easiest thing to find is the measure of angle y right here. So measure of angle y, that's going to be one of our answers. It's the easiest because we know that this angle is 90, this angle is 52, so we just add 90 plus 52, we get 142, subtract that from 180, and we get 38. So the measure of angle y is 38 degrees. That's one of our answers. We can put it in there. Then we got to find the other two sides. Remember, when we're naming these sides, easiest way to name it, if it's across from x, then we'll call this little x on this side. This is z, big Z is over here, so we'll call this little z on that side. So we'll just find little x and little z. I'll find little x first, doesn't really matter which one. And you can pick whichever angle you want to use. Let's go with, I'll pick the 52-degree angle. It's easier to do one than the other, a little easier, but it's not really all that much easier, so it's still the same stuff. We label the triangle, that's your opposite leg. Side across from the right angle is the hypotenuse. Every time label the triangle. This side over here is the adjacent. Since I'm trying to find x, I'm dealing with the opposite leg, and I want to deal with the part or the side that I know, which is the adjacent. So again, the SOHCAHTOA, we're doing the TOA part this time because we're dealing with opposite and adjacent. So that's the tangent. So the equation we're going to set up is tangent of our angle that we picked, which is 52, equals the opposite, which is x, over the adjacent, which is 8.5. Same stuff over again. We grab our calculator, we punch in tangent, don't hit second because we're not finding the angle. Tangent 52, we want to get rid of this word, change it into a decimal form. It's 1.2799. Put a 1 underneath that. Not sure what's wrong with my pen today. X over 8.5. We cross multiply. 1 times x is just x. Cross multiply this way. This is one of the easy ones because we're not going to have to divide by anything. We just have to multiply here and get the answer. So we take 1.2799 times 8.5, and we get 10.879. So we'll round that to 10.9 since it's a second. So we got 2 of our answers. We now know that this side over here is 10.9. We know this side's 8.5. We could do the same thing, sort of use the trig ratios like we did here and set up an equation to find the hypotenuse. This time I'm going to use Pythagorean theorem to do it. Doesn't really matter which one, you do whatever's easiest for you. And with Pythagorean theorem, these are the 2 legs. This is the hypotenuse, so it's going to be 8.5 squared plus 10.9 squared equals little z squared. And I can plug all this right into my calculator and do 8.5 squared plus 10.9 squared, and I come up with 191.06. That equals z squared. And then to solve that, we just have to take the square root of both sides. Remember, you take the square root here, those cancel out, and you're left with just z. Now we take the square root of 191.06 on our calculator, and we end up with about 13.8. So those are our 3 answers. The last thing I would do on this side's 13.8. I would check to make sure that my answers make sense. Remember, the hypotenuse has to be the longest side, which it is. make sure all my angles add up to 180, which they do. Not sure why this says type the equation in here. I must have forgot to get rid of something. On this one, we know all three sides, and all we're doing is we're finding alpha and beta. First angle, you're going to have to use the trig ratios, the SOHCAHTOA. So we pick one of them. I'll pick alpha first. We know that, and I'll label the triangle accordingly. That's the opposite leg. That's the hypotenuse. This is the adjacent leg. Now if I'm doing this, I'm probably trying to stay away from that square root of 3 because it looks a little harder than just the numbers 1 and 2. So I'd probably pick these two sides to deal with. You could pick whichever ones. You could use you could use any of the three trig ratios to solve this, but I'm going to use opposite and hypotenuse, which opposite and hypotenuse is the SO part. Opposite hypotenuse, so that's the sine. When I set up my equation, it's going to be the sine of our angle, which we don't know, sine of alpha, then equals, and then the fraction. And it's opposite over hypotenuse, so it's 1 over 2. Once we set up the equation, since we're looking for an angle, the calculator is going to do all the work for us, so we just grab our calculator. Remember on these, when you're looking for an angle, that's where you got to hit that second or shift button, depending on which calculator you have. I keep forgetting about the shift. Some of them, you have to hit the shift button. So we hit second, sine, and then we just put in 1 divided by 2, close the parenthesis, and we end up with alpha equals 30 degrees. So we now know that this is 30 degrees. Sorry on this one, we're only going to get 2 answers because I gave you too many parts. Should have left one of the parts off, which I didn't. Now to find beta, the easiest way to find beta, we know this is 90, we know this is 30, and you probably don't even have to do this because we talked about what kind of triangle has a 30-degree angle and a 90-degree angle. But if you need to have your memory refreshed, that other angle, that beta, has to be 60 degrees. 30, 60, 90 triangle. And if you remember the 30, 60, 90 stuff, in a 30, 60, 90 triangle, if you remember, the side across from the 30-degree angle was labeled x, the side across from the 60-degree angle was labeled x times the square root of 3, and the side across from the right angle was labeled 2x. Well, if we look at this, just the way this is, side across from the 30-degree angle was x, so this tells us x equals 1. So we know that that side should be 1. Side over here, the hypotenuse, should be 2 times 1, which is 2. And this one over here should be 1 times the square root of 3, which is just equal to the square root of 3. So if you'd remembered that that's the 30, 60, 90, then we wouldn't have had to do any of this work. You could have just used that. Next one. If we solve this triangle, we're looking, we'll find C first. And the easiest way to find C is just use Pythagorean's theorem. 2 squared plus 3 squared has to equal little c squared. 2 squared is 4, 3 squared, you can plug all this into your calculator. 3 squared is 9, and just plug that whole thing in there. 4 plus 9 is 13. And then we just take the square root of both sides. So the square root of 13, if you left your answer as the square root of 13, I wouldn't throw a big fit there. If you wanted to change it to a decimal, then you grab your calculator and you hit second square root 13, and you come up with we'll say about 3.6. Either one of those answers would be acceptable. Square root of 13 is the better answer because it's not rounded off. Now, if I'm trying to find the angles, I pick one of the angles that I want to find. Maybe we want to find A first. That's the opposite leg. We gotta label the triangle. That's the hypotenuse. This is the adjacent leg. I would probably deal with these two because they're regular numbers instead of the radical if you don't want to deal with the radical. So we're dealing with opposite and adjacent. SOHCAHTOA, the TOA part. So we're using the TOA part. That tells us tangent. So when we set up our equation, it's the tangent of our angle, which is angle A, equals opposite over adjacent. Well, the opposite is 3. The adjacent is 2. And then if we're looking for an angle, our calculator is going to do all the work. So we just hit second, tangent, 3 divided by 2. It equals, and we get 56.3099. So we're going to say the measure of angle A is about 56 degrees. Once I know angle A is 56 degrees, I could find angle B by adding these two and subtracting from 180. I'm going to find it using the trig ratios again, just another way to do it. All right, this time if we're looking for angle B, what changes is now instead of that being the adjacent leg, now that's the opposite leg. This is still the hypotenuse, and this is the adjacent leg. Well, we still probably want to deal with these two because they're just regular numbers. So we're still doing tangent of angle B equals, it's opposite over adjacent, so this time it's 2 over 3. It's just the inverse of that right there, and if you know that, you wouldn't have to go through relabeling it and everything. You could have just set it up like this and then solved it that way. So we hit second, tangent, 2 divided by 3, and I end up with 33.69, which means we'll round that up to about 34. So angle B is about 34 degrees. And if you add these three angles up, they come up to 180. So these are our three answers. All right, some word problems. This isn't actually a word problem, but it's sort of a word problem. It's one that I've already drawn the picture for you. And we have this stage, and we're trying to figure out what angle the stage is at. The back of the stage is 2 feet tall. This length in the stage is 30 feet long, and we want to find this angle. So if we're looking for that angle, we label the sides. That side over there is going to be labeled the opposite. Side across from the right angle is the hypotenuse. This other side is called the adjacent. These are the problems where you got to decide what you're using and what you're not using. This time we're looking for this angle, and we know these two sides, so those are probably the two that we're using, and we really don't care about this adjacent side. So when we go to set up our equation, we're using opposite and hypotenuse, which is the sine. So we do the sine. This is our equation. The sine of our angle, which we don't know, so that's x, equals, and we're using the so part, so it's opposite over hypotenuse. The opposite this time is 2. The hypotenuse is 30. This is a nice one again because we're just finding an angle. So that angle is we just punch it in, our calculator is going to do all the work for us. So we just do second sine 2 divided by 30. Punch that all into your calculator, hit equals, and you come up with about 3.8. So we're going to say that x is about, we'll round it off to about 4 degrees. And that's the only answer they asked for this time, is what that angle is there. And that would be an angle of elevation. So what's the elevation of the stage? About 4 degrees. Next one, how tall is the lighthouse? So we're looking for this side over here. This is big A, we'll call it little a. We're probably going to use this angle since they gave it to us. It looks like an angle of elevation there. So this is going to be the opposite leg. This is the hypotenuse across from the right angle. Hopefully the lighthouse makes a right angle with the ground. And then this side over here is the adjacent. We really don't care about the hypotenuse this time, so we care about the adjacent and the opposite. You pick your trig ratio. One that deals with adjacent and opposite is the TOA part of SOHCAHTOA. So that's the tangent. So we do tangent of our angle, which is 72, equals tangent's opposite over adjacent. So that's going to be A over 40. We grab our calculator. This time we just do tangent of 72 equals 3.0777. Remember, it's all right for tangent to be larger than 1. Sine and cosine can't be larger than 1, and if they are, then your calculator's not set up right. We put a 1 underneath that. We cross multiply. 1 times A is just A. This is a nice one because all we got to do is do this other cross multiply, and it's going to be our answer. We don't have to divide. So I take 3.0777 times 40, and I end up with 123.1. Since we're finding the side, we round to the nearest tenth. And this time, our units were meters. So the lighthouse is about 123.1 meters tall. Next one, a cable is attached to a pole 10 meters high. If the other end is attached to the ground, 8 meters from the base of the pole, how long is the cable? You have to draw pictures on these so that you understand. Also, if at any point you understand what you're doing, then don't sit here and watch me do these videos. Go ahead and do the work and check your answers afterwards, make sure that they're correct. And then if you need to, go back and watch some of the end as I'm doing these examples so that you can figure out how to do them. But again, on this one, you have to draw a picture. On a lot of them on the homework, you have to draw a picture. So it says the cable is attached to a pole that's 10 meters high. So this is my pole. We know it's 10 meters. Doesn't have to be a spectacular drawing, just got to be some kind of drawing. And we got a cable that's attached to the to the pole. Comes out here like that, so it's attached to it, and it's 8 meters from the base of the pole. It says 8 meters from the base. Hopefully the pole makes a right angle with the ground, so we'll put a right angle symbol in there. How long is the cable? So we're trying to figure out how long this cable is. That's going to be our X. We could find one of the angles here and then use sine, cosine, and tangent, figure it out. Or we could just use Pythagorean's theorem. A squared plus B squared equals C squared. This is a leg, this is a leg, this is a hypotenuse. The other thing that we could use, I've been yelling at my son because he's been doing some problems sort of like this. And if you remember this stuff, it makes everything so much easier. It might fit one of the families. But now that I look at this one, it doesn't fit one of the families. So be careful of that. So we're going to use Pythagorean's theorem. Ignore this crazy line going down through here. This is a leg. This is a leg. That's our hypotenuse. So we do 10 squared plus 8 squared equals C squared. I would punch all this right into my calculator. 10 squared plus 8 squared equals 164. Then you got to take the square root of both sides. So we just take second square root, 164, and I end up with about 12.8 meters. So the length of the wire about 12.8 meters. Suppose a tree 40 feet tall casts a shadow 60 feet long, so we got our tree. It's my tree, it casts a shadow coming out here. Remember some of the shadow problems that we did? They tell us the tree here is 40. Remember that little mark there means 40 feet. When it's just one mark, it's 40 feet. When it's two, those little tick marks, it's 40 inches. And the shadow is 60 feet. What is the angle of elevation with respect to the ground from the end of the shadow? So the angle of elevation is going up. You're looking at the top of the tree. This is what we're looking for right here. We're going to call it theta. So we're trying to find theta there. So we're dealing with that angle. That's the opposite leg. Hopefully the tree makes a right angle with the ground. That's the hypotenuse, and then this side is the adjacent leg. The ones we care about this time are these two, the opposite and the adjacent. We really don't care about the hypotenuse this time. So we set up, or we figure out which trig ratio we use. Well, the trig ratio that uses opposite and adjacent, that's the TOA part of SOHCAHTOA. So we're going to use tangent of theta, because that's the angle we're looking for, equals opposite over adjacent. So 40 over 60, ignore all that stuff. And since we're finding an angle, we just grab our calculator and we hit second, tangent, 40 divided by 60, it equals, and we end up with 33.69. So we'll round that off and say that theta is about 34 degrees. So the angle of elevation from the ground to the top of the tree is about 34 degrees. The angle of elevation from the top of a small building to the top of a nearby tall building is 47 degrees. The angle of depression from the top of the small building to the bottom of the tall building is 15 degrees. If the smaller building is 30 feet tall, determine the height of the tall building. Some of these are a little harder than others. I got my two buildings here. I got my short building, I got my tall building. It says the angle of elevation from the top of the small building to the top of a nearby taller building is 47 degrees. So if I'm looking here straight across, and then I look up at the top of this, they're telling us that that angle right there is 47 degrees. And the angle of depression from the top of the small building to the bottom of the taller building is 15 degrees. Don't go by my picture because it looks like I've drawn it completely wrong, but that angle of depression from right here should be about 15 degrees. If the smaller building is 30 feet tall, so they're telling us that this building right here is 30 feet tall, how tall, or what is the height of the taller building? So if I draw this in, now what we have, if this is 30 feet, then this over here has to be 30 feet. That doesn't mean the second building is 30 feet tall, but up to here on it, where we're looking straight across at it, is 30 feet. So what we need to find is this part right here. So if we use this triangle, we know this 90 degrees hopefully. We can use that triangle, and we know this side's 30, and we can find the length of this side, which is part of this top triangle. Then we'll use it to figure out what this part is. So if I'm just splitting off, if I split off that triangle, you know, this is 90 degree angle, that's 30 feet. I think it said 30 feet, right? And this is a 15 degree angle, and I want to find this side. We label it according to the 15 degree angle. That's our opposite leg. That's our hypotenuse. This is the adjacent. Well, we're looking for that side, and we know that side. So the first equation I'm going to set up is using opposite and adjacent, which is tangent again. So we do the tangent of our angle, which is 15 degrees, equals the opposite over the adjacent, so 30 over x. We grab our calculator, and we do the tangent of 15. Tangent 15 equals 0.269, or I'm sorry, 2679. 0.2679. Put a 1 underneath that. That equals 30 over x. We cross multiply, we get 0.2679x equals 30. When we cross multiply that way, now we're going to divide both sides. And again, if you can shorten these up by skipping a step or two here and there and just not writing all this down, it makes everything a whole lot easier. So x, we divide 30 by that. 30 divided by 0.2679, and we get 111.98. So we're going to round that off to 112.0. So that means the distance between the two buildings here is 112 feet. Well, now we got this second triangle up top here, and we know it's a right triangle. And this angle is 47 degrees. Again, don't go by my drawings because they look horrible. This doesn't look like a 15-degree angle, and that doesn't look like a 47-degree angle. I know that this side over here is 112. That's how far apart the buildings are. Now we're looking for this side. So I'm going to call it, we'll call it y instead of x. We're dealing with the 47-degree angle. That's the opposite leg. That's the hypotenuse. This is the adjacent leg. We know that one. We're trying to find that one. So it's opposite and adjacent. Well, that's tangent again. So it's tangent of our angle, which is 47 degrees, equals the opposite, which is y, over 112. That's our equation. We do the same thing on our calculator. We hit tangent of 47, and it gives us 1.0724. That equals y over 112. Put a 1 underneath this. It's a nice one because all we got to do is cross multiply here and it's going to give us the answer. So we take 112 times 1.0724, and I get 120.1. Again, that's this distance. So this distance right here is 120.1. Again, this doesn't look like 120.1 compared to my drawing where this is 30. Now they wanted the height of the entire building, of the entire taller building. Well, all we got to do is add those two up. So the height of the tall building, I'll just say tall is about 150.1 feet. So we had to set it up a couple of times there, and some of the problems you're going to have to do that. Next one, two players stand on a basketball court. The angles of elevation from the foot of each player to the 10-foot high basket are 40 and 50 degrees. How far apart are the two players? So we got our basketball goal here with our rim on it. Spectacular basketball goal. And we got a player standing here. Got to have our ground here. Player standing here. Their angle of elevation is 40 degrees. Let's make it 50 degrees. It's 50 degrees. And then the other person is standing farther away, and their angle of elevation is 40 degrees. Hopefully the basketball goal makes a right angle with the ground. Again, we got two triangles. We start off with the first one. It's 50. It's a right angle. We're looking for, and we know that this is 10 feet. Sorry, I didn't write that in over here. Hopefully the basketball goal is 10 feet tall. We're looking for how far this person is from the goal. So that's X right there. We label this triangle. That's your opposite leg. That's your hypotenuse. This is your adjacent leg. Those are the two we care about. Adjacent and opposite, or opposite and adjacent. So again, we're doing tangent 50 degrees equals the opposite over the adjacent, so 10 over x. We figure out what the tangent of 50 degrees is on our calculator. Tangent 50, it equals, and it's 1.1918. Put that under, or a 1 underneath that. 10 over x. We cross multiply. And this one we're going to have to divide. I'm not going to show all this work this time. I'm just going to do it on my calculator. We cross multiply and we get 1.1918 times x equals 10. So we divide 10 by 1.1918, and we end up with x equals about 8.4. And we're using feet. So the first person here is about 8.4 feet from the basket, from the bottom of the basket, or the bottom of the pole here. Actually, the bottom of the, where the basket comes straight down. Then we got to do the second person. It's going to be the exact same setup. Their angle of elevation is 40 degrees. We know that this is 10 feet. And we're looking for this right here. We'll call it y this time. That's your opposite. It's the exact same setup. That's your hypotenuse. This is your adjacent. They're dealing with those two. So it's a tangent. This time, instead of tangent of 50, it's tangent of 40 equals 10, over y. We take our calculator, we find the tangent of 40, so you punch in tangent 40, and you get 0.8391. Put a 1 underneath that, equals 10 over y. Same thing, you cross multiply here. So you're going to end up with 10, and then you're going to divide it by this number. 10 divided by 0.8391, and we end up with y equals about 11.9. So one person's 8.4 feet from the basket, the other person's 11.9 feet from the basket. They ask how far are the players from each other. So what we got to do with that is we got to take 11.9 and subtract 8.4. 3.5, so they're about 3.5 feet apart. Mr. Harrison wouldn't be too happy if somebody was guarding their guy 3.5 feet from him, but that's about how far apart these two people are. Next one, slope of a ramp is 1 over 11. So first thing I'm going to do here, I'm going to draw me a little ramp. If they're talking about the slope, ignore this. If they're talking about the slope, remember it's rise over run. So the rise of the ramp is 1. The run of the ramp is 11. Hopefully the ramp is the right angle right there. What is the angle of elevation of the ramp? Well, the angle of elevation is going to be this angle down here. So we're looking for that. Let's call it alpha this time. So to find alpha, we just label our triangle. That's your opposite. That's your hypotenuse. This is your adjacent. We care about these two this time, or those are the two that we know this time. Opposite and adjacent, every single one of these has been tangent. That wasn't, I didn't set it up that way. It could be sine, cosine, whatever. So this is tangent of alpha equals opposite 1 over 11. Then we grab our calculator and we're looking for an angle. So remember, you got to hit second or shift button on your calculator first. So we hit second, tangent 1 divided by 11, and we end up with 5.19, or about 5. Since it's an angle, we'll just say about 5 degrees. So alpha is about 5 degrees. So the angle of elevation of that ramp is about 5 degrees. These are all just different ways that these problems could be set up. This one, I'm not actually going to do this one, but I'm going to draw it. So you got an observer, they're standing on a cliff. That's my person. Ignore all that extra stuff going up through there. They're standing on that cliff. The cliff is 1,200 feet above sea level, so 1,200 feet here. 2 ships due east. Whichever way east is, it doesn't matter. The angles of depression to the ships are 48 degrees and 33 degrees. So we got 2 ships out here in the water. That's my first ship. That's my second ship. Angle of depression to this ship, 48 degrees. So we have a right triangle there with one of the angles being 48 degrees. Angle of depression, sorry, that should be 33 degrees, closer ship. Angle of depression to the ship that's farther out here is going to be 48, so this whole thing right there is 48 degrees. Sorry, my pen's messing up so bad. We could find this angle if we needed to. We don't really need to. They want to know how far apart the ships are. So what you're going to do is you're going to split off the 2 triangles. Know that this one's 33 degrees. That's a right angle. This is 1,200. We're looking for this side. Then we got the other one. This is 1,200. This angle up here is 48 degrees. That's a right angle, and we're looking for this side. They want to know how far apart the ships are, so once you find those 2, you'd subtract. But main thing, be able to draw this picture here so you know how to set it up. Ignore the assignment is the worksheets on Moodle. If you have questions, feel free to send me an email, give me a call. I'll try to make another video send to you, or I'll call you and help you through problems, whatever. I know these are difficult when I'm trying to explain them this way.